Electrostatic discharge. This is the shock you get when you scuff your tube sock along the floor, reach for a doorknob. You get that shock, just like the tube sock video. Notice he's charging with friction. Want to see it again? There's that shock like when you hit the doorknob. So, if we look at it really closely, here's what's going on. The tube sock now has got a bunch of extra negative charges from scuffing across the floor, and as a result the tongue has negative charges in it. They get pushed away by those negative charges in the tube sock, leaving behind positive charges there at the end of the tongue. And then that charge buildup is so great there on the sock that it just jumps over. And that jump over is the spark that you see, where the electrons actually heat up the air itself as they travel between the sock and the tongue. There's no actual contact here. This is just charging by induction, and then polarization, and then the discharge is the movement of those charges suddenly from the sock over to the tongue. Sock to the tongue. Sock to the tongue. Part of that electrostatic discharge that we just observed has to do with the idea of grounding. Nature always behaves towards being electrically neutral, meaning when there's a buildup of charge like was on the tube sock, there's a behavior that happens in nature then to move those charges so that everything is neutral, as we saw there. And what happens then, if you're like all excess charged up and everything, those charges are going to try to go somewhere where everything's going to be neutral as a result. So the idea is for them to go into the ground, and if there's a way to get there. So the man that was sitting there in his chair is got his feet on the ground, and so the charges have a way to go not just onto him, but then move on down into the ground, leaving the sock neutral, leaving the man neutral as it goes on down through. If you're just walking across the floor and you touch the doorknob, the door is attached to the frame in the wall, which is attached to the house, which is sitting on the ground. Everything's grounded, so the charges can simply flow from you through all that into the ground. Then you might wonder, well, then the ground's going to be charged. It turns out the ground is hardly affected because the earth itself is just this big, huge reservoir of charge. I mean, it's just, there's so much stuff there, and everything that makes it up is made up of atoms, which is made up of protons and electrons, and it's all pretty much neutral, and you have this huge amount of charge. So adding the charges that are built up on you or built up on that tube sock really don't make much of a difference. It'd be like actually putting food coloring in water. Alright, so just putting some food coloring in here, some dye into this pool water here, you can see how quickly the dye itself just goes away. You can't see it. It's not turning all the water a dark blue color. There's so little of it compared to all the water, there's hardly any noticeable effect from that dye. So the same thing is true with the charges that come off of things and get grounded. All those charges dump into the earth and they spread out just like that dye spread out in the water. And now for my public service announcement to finish this thing up here today. You ever noticed at the gas stations, the little signs they have, whether they're on the posts or on the gas pumps themselves, talk about some different dangers and things to be aware of. Let's take a look at this first one here. Do not leave or re-enter vehicle while fuel is pumping. Static electrical charge can cause fire. So it turns out when you sit in your car, you gather charge by contact and you take it with you when you get out. The fuel nozzle itself is grounded to the pump. So here's a young lady comes in to fuel up her car, and you can see she's, tugging and pulling and getting the charging by friction on her sweater there. She goes through all the preliminaries of, oh, it's grounded. Here we go. She's good now, right? She's discharged because she's touching that grounded nozzle. And there you go, right? Still making sure we got some good charging by friction here. Oh, not enough. That's good. And here's the problem. She gets back in the car, has a seat, and I skip through it. Sometime later she comes out and boom, there you have it. Alright, and of course probably shouldn't take that out. Fortunately for her it wasn't still pumping, so it wasn't a flamethrower. So let's look at what actually happens here. She's charged up, got a lot of excess charges on her, and the grounded nozzle is right there. She charges it by induction, and there's enough charge buildup here to jump across with a spark. That spark heats up the gasoline fumes, which ignite on fire. Right, again, it's the fumes of the gasoline that are flammable, and they're all coming out of the opening here, and as a result, fortunately for her, it's just the fumes burn and there's no air inside the gas tank, so as a result there is no explosion. Worked out pretty well for her overall. Let's see, the other part of that sign there, fill portable containers on the ground. If they're not grounded, then the charges that might build up on them don't go anywhere. And so you get a similar issue here as we had with the young lady. This gentleman here is filling up his gasoline container in the back of the truck. There's a charge buildup, it's a spark. Unfortunately for him, it is still pumping fuel, and as a result it's basically a flamethrower when you look at it. So if we go back right about here, there was a spark that charge had built up, and as a result the fire spread quite a bit in that case. So again, with all these ideas looking at it here, just be aware of electrostatic discharge around flammable things. That tiny little spark can do a lot.